Morning all. In our last lecture we discussed about query optimization and query trees as well as query graph, etc. Today I will be going to see with an example how heuristic optimization of query trees is to be done. Okay. The same query could correspond to many different relational algebraic expression, hence many different query trees. As we know, for a given query you can have different relational algebraic expression. That means different query trees are possible. The task of heuristic optimization of tree is to find a final query tree that is efficient to execute. An example: consider three relations: employee, work zone, and project. Employee with attribute fname, lname, ssn, birth date, etc. We mention those attributes which we are interested only. Work zone with ESN, P number, hours, P number, P name, project with P name and P number. A query is something like this. We want to retrieve those employees working on a particular project whose birth date is greater than a particular date. Select lname from employee, work zone, project, where the condition is the project name is Aquarius and birth date is 31/12/1957. Those employees whose birth date is greater than this and who are working on a particular project Aquarius, those records only that we are interested to retrieve. Then the initial query tree will be a tree with three nodes corresponding to three relations, that is employee, work zone, project, and clubbed together with Cartesian product. Then the select condition in the where class, and finally final node is a project operation with the attributes that are required. For initial query tree will be something like this: three relations employee, work zone, project joined with or clubbed with Cartesian product. Then this select condition, the whole condition is like this: P name is Aquarius and P number should be equal to P number, ESSN should be SSN, and birth date is greater than this. And finally a project operation with lname. Lname is the attribute that we want to retrieve. And what is next is moving the select down the tree. Now this is a select condition out of which birth date greater than 12/31/1957 is applicable only to the employee relation. When you apply this condition, what ultimately the result is the size of this employee relation will be reduced. Consider an example. Let the employee relation is having 1000 record. Those employees with birth date greater than this date is let be 100 only. By applying this condition, the resulting relation will have only 100 tuples against the 1000 in the original one. Similarly, when this condition is applied, because this is a project relation, the project relation one tuple for each project. If that is the case, then sigma of P name is equal to Aquarius. This condition is applied, this will return only one tuple. And similarly, this equality conditions on this Cartesian product, again a equality or the sigma select condition is applied. That is how in each case the employee, when this condition applied, tuple reduced. Then these two condition, that is a Cartesian product, the number of tuples will increase. Let n is the number of tuples in employee and m is the number of tuple in work zone. Then the Cartesian product will be having n into m, that many number of tuples. Cartesian product will always increase the number of tuples in the resulting relation. Then again a select is applied, again the number of tuples in the condition is in the resulting relation is reduced. Similarly here also Cartesian product, then a condition, then again a projection on this one. Now the third step is this is an intermediate tree. Third step is if these type of conditions like this is a condition, when it is applied, that may result only one tuple, whereas this may tuple a set, this may result in a set of tuples. Such type of relation, if we can swap, then resulting tree will be more efficient. That is why we sapped the project as well as employee, because the reason is only simple. This project relation returns only one tuple, may result only one tuple, whereas the employee relation, when this condition is applied, may result in more than one tuple. Our ultimate aim is reduce the size of operations to the maximum as possible. That's why the third step. This type of step may not be possible in all the cases, but this is a step that mandatorily should be applied. This, if possible, should be applied. Okay, this third step. After the third step, project, this condition applied, then a Cartesian product, then a select. Similarly, employee, this condition is applied, select is applied, then Cartesian product, then select, and final pi operation. And what's the next step possible? Fourth step, D, then fourth step possible. You know, the Cartesian product followed by a select is a join operation. A join is join of R and S, means Cartesian product of R and S, and a select on the common attribute. That is what a join here. Here, when the project as well as works on joined on project number, that means a Cartesian product followed by select. Therefore, this Cartesian product followed by a select can be replaced with a join. Here also, a Cartesian product on SSN and Cartesian product on this relation as well as this, and followed by a select on SSN can be replaced with a join. Therefore, fourth step is replace the Cartesian product followed by select with the join operation. Therefore, our resulting tree will be something like this. Project, this condition is applied, joined on P number. Birth date, employee, this condition is applied, joined on this. Now the last step of our optimization. Keep only attribute needed for subsequent operation in the intermediate relation. In the intermediate relation, actually we want to join together project and work zone. On which attribute? The attribute is P number from work zone and also P number from project. Therefore, these are the only two attributes we are generally interested. But there should be the bare minimum number of attribute from each one. Therefore, you can apply a project operation. Here P number as well as this P number is important, that we are going to join on the P number. But the ESSN is also required. Why? ESSN, the resulting relation when these two work zone joined with project with the projected attribute of P number as well as ESSN P number will result only in two attributes, that is ESSN and P number, because P number, this is a common attribute, therefore resulting relation will be having resulting relation will be having two. If it is a common, it's not natural join, therefore it can say three attribute. P number, this is same common. If common attribute is removed, then it will be having only two attribute are ESSN and project number. Now in this join relation, what we are interested is only when we want to join together the employee with the resulting relation from the subtree. There also we are interested only in SSN, and here SSN and LName. LName is the data that we required. Therefore, from each of the relation you can apply a project operation with the bare minimum set of attributes that are required in each of the subtree evaluation. That is how here from this subtree you execute and return a resultant relation of which ESSN is the only attribute that we are interested. Similarly, from this one, SSN as well as LName, you can join together on ESSN as SSN. Therefore, resulting relation what we will retrieve is LName. This is how the final optimized tree is obtained. The final step, the fifth step, is keep only attribute needed for subsequent operation in the intermediate relations. From fourth step to fifth step, that is an important crucial step where we will apply the project operation. by projecting those attributes which are barely needed in each of these steps to high steps. Okay, from the initial tree of this one we got a final tree which is an optimal uh, tree corresponding to a relational algebraic expression. The final expression, you can say, this is on this project relation you apply sigma and a pi operation there, pi there, or the project there, and here also works on a pi ESSN in a p number is applied, and these are joined together, and finally from this subtree also joined together, and finally you got this is the optimal expression or tree corresponding to the initial SQL query. For this way you can have a query optimization, a heuristics way of applying, that is by rearranging the operations you can have a optimized uh, query expression. Thank you.